what product rule is designed to do is to have the ability of being able to take the derivative of two functions. And two functions which are multiplied together. Sometimes, in this particular instance, I could write this as x to the 1/2, clear the parentheses, and just use power rule on it. Many times you can't do that. Most of the time you can't do that. So therefore you have to have a set of rules that would allow you to be able to take the derivative of two functions or more multiplied together, and this is essentially the formula for product rule. If you have f of x equals to g of h times g of x times h of x, that's the product of two functions. What is the derivative? So the derivative of f with respect to x is, which is f prime of x, the derivative of the first multiplied times the second plus the first function times the derivative of the second. Now what I remember is everybody gets a turn being differentiated. So I look at the two functions, and by the way, if you do it the other way around, that's fine, but in each single term only one function gets differentiated, anything else stays the way it is. It's the derivative of the first times the second, not differentiated, plus, I've already differentiated the first times the derivative of the second. And like I said, to me, it's everybody gets a turn being differentiated. So if I were to look at this guy as my first example, 400 is a constant. Remember when we were taking derivatives, we brought the constant, just held him on the outside, did everybody else if you wanted to. So that says 400 is a constant, and so I'm going to leave him alone so that y prime is 400 times, now the derivative of the first with respect to x times the second added to the constant 400. I've already differentiated the first times the derivative of the second. Now, by the way, you don't have to put this in if you can do it in your head. Most of the time after you've done a few, you'll just look at it and just do the derivatives automatically without putting this notation in. I'll put the notation in over and over and over as we go through until it looks like I can leave it out. So now I just simplify. It's 400 times the derivative of 15 minus x squared is what? 15 is a constant. The derivative of a constant is 0. Minus, and this is going to be times a minus. In fact, let me put the 0 in. So it's 0 minus the derivative of x squared is 2x. So that's the derivative of the first times the second plus 400 times the first times the derivative of the second. The derivative of 3x is 3 minus the derivative of 2 is 0. Then you simplify. Well, this is 400 times a minus 2x times 3x minus 2 plus 400 times 15 minus x squared times 3. These guys are going to be a pain. This then is minus 800x times 3x minus 2 plus 3 times 400 is 1200 times 15 minus x squared. And I'm just going to leave him that way. I can multiply it through combined like terms, but I'm going to quit while I'm ahead. We can simplify this more. But we're not going to. Where the algebra, by the way, is important, I will. But you guys can remove parentheses, combine like terms. Besides, I didn't leave myself enough room, which was not a good idea.
So if we get that answer on the test, we're fine?
Oh, I usually actually take it to the first step. So where you would be fine is either here or here on the test. On application problems, you're going to have to take it down. You don't have a choice. But when we do the derivatives, my derivatives that I give you on exams aren't designed to be simplified. On the quiz, you'll probably have to do some simplification. But I rather focus on the algebra, which is important, rather than the algebra that's not important. Yeah?
Can you just go over really quickly how to find the derivatives?
We're just using power rule.
What is that?
We spent a lot of time on power rule. Well, maybe you can catch on whenever we move forward. So, I'm going to have to rewrite the square root. Remember what square root is? 1/2. So, I'm going to have to rewrite him. He is going to be negative 3 times 5x cubed minus 2x plus 5 times x to the 1/2 plus 2x. Now, if I wanted to save myself some pain, I could multiply the negative 3 through, couldn't I? If I wanted to. 6 and 1/2 dozen the other. But we're going to use product rule, so we'll just leave him alone. It's going to be negative 3 times the derivative with respect to x of the first times the second plus a negative 3 times the first times the derivative of the second So here we go. Negative 3 times. What's the derivative of 5x cubed? 15x squared. So that means that this set of parentheses is going to get differentiated. I forgot somebody, didn't I? The derivative of the first times the second. This should be in here. Oh, it is already in there. Gracious. Visually, I looked down at that thing and I didn't see it. I wonder, I don't know, it just might be Friday. It's there. That's because, do you know what I did? What did I do? Put that set of parentheses right there. Screwed myself up. Let's do that, and I'll save myself from myself. So, we said the derivative of 5x cubed is 15x squared minus the derivative of negative 2x is negative 2 plus the derivative of 5 is 0 times the second. By the way, I don't normally write 0 in there, but we will not for the time being. Plus negative 3 times 5x cubed minus 2x plus 5 times the derivative of 1/2 plus 2x. What's the derivative of x to the 1/2? X to the negative 1/2 plus 2. And that's where I would leave it.
What's the negative 1/2?
Pardon me? Remember, it is nx to the n minus 1. So what's 1/2 minus 1? Negative 1/2, yeah. Those are the ones, halves and thirds you'll be able to work with pretty easily for some odd reason. Anything bigger than that ends up being a pain.